bubble sort. Like selection sort, bubble sort involves dividing the original list into a sorted section and an unsorted section. Its name refers to how the elements bubble up to the sorted section, located at the end of the list. This is accomplished by iterating through the list multiple times, swapping elements with their neighbors if they are not in the correct order. Each iteration is called a pass. At the end of each pass, the largest unsorted element will be positioned at the end of the unsorted section, which then becomes part of the sorted section. As you can see, this potentially requires many swaps for each pass, but we'll worry about that later. Let's take a look at the inner workings of this algorithm to see exactly how it works. Here we have an array of 4 cards, which is initially labeled as unsorted. The inner loop executes a single pass through the array, while the outer loop enables that pass to run multiple times. We start things off by stepping into the first pass. We'll be keeping track of how many comparisons are made in each pass. The letter C stands for current and will represent the element at our current position, while N stands for next and will represent the next element. Current always starts out at index 0. From there, we compare current to next and advance the larger of the two to be compared with the following element in the list. 6 is not greater than 7, so we simply increment current and try again. This time current is greater than next, so we advance 7 up the list by swapping it with the 2 of clubs. Then increment current again. 7 is greater than 4, so they are swapped, positioning the 7 at the end of the unsorted section. It now becomes part of the sorted section and thus no longer needs to be compared against. Now for the second pass. As stated before, current starts at index 0 and is compared against the next element. 6 is greater than 2, so they are swapped and current is incremented to index 1. Again, 6 is greater than 4, so they're swapped. All elements have been compared, so 6 joins 7 in the sorted section. Time for our third and final pass. 2 is not greater than 4, so there's no need to swap. 4 becomes part of the sorted section, leaving the 2 of clubs as our lone remaining element. However, the last remaining element will always be in its correct position.